Hi everybody. Ready for lesson 2 of chapter 8. Today we're going to talk about area of two specific shapes, parallelograms and triangles. Now remember that parallelograms can look like a typical parallelogram, meaning like a rectangle that kind of leaned over a little bit, but a square is a parallelogram, a rectangle is a parallelogram, a rhombus is a parallelogram. Okay, so this is in regard to all of those kind. When we are finding area, as we stated in the last lesson, we are looking at a two-dimensional part of this shape, the entire inside. So the length and the width all at the same time. Because the typical parallelogram is this leaned over type shape, we use words called base and height rather than length times width. But I did want to make sure that you knew that if we had, let's say, a square or a rectangle, then we would be looking at the height and the base, the height and the base. And the one thing that would be a little bit different is that sometimes you will see it called the length and the width, so L and W. For a square, since all four sides are the same length, you will sometimes see an S for side. And since it would be side times side, sometimes they show it as, can you think what I'm going to put up here? Side squared, side times side. Okay? All right, let's keep that in mind as we talk about our parallelograms. The base of the parallelogram is going to be the length of one of the sides. Usually we think of that as the bottom. Doesn't have to be. It could be the top, because remember, in a parallelogram, the opposite sides are parallel and congruent. Okay? So it wouldn't matter which one you use. They would be the same number. The height is what is a little bit different. The height, and this is one of your vocabulary words, and this is the key part right here. The height is the perpendicular distance between the bases. So in a shape like a rectangle that has 4 right angles and a square, you don't have to draw an extra dotted line like they've done here. You already have that right angle, and so you don't have to draw a new thing. But on a parallelogram, you do. You have the perpendicular distance between the bases is not a line that is part of the shape. This length of this side is not the height. It's longer than the height. Now, you'll notice from the two drawings here that you could think of the height, between the bases as inside the shape or even outside the shape. It doesn't matter. It's still the distance between the two bases. And here is our formula for the area of a parallelogram. It's the base times the height. So let's say that this base is 10. That doesn't look very good. Let's make that again. Okay, it's 10, and the height is 6. So we're going to multiply them together. The area would be 60. Now, whatever kind of units we're using, whether we're using millimeters, yards, inches, kilometers, it would be a square unit. Remember, we talked about that in lesson 1. So let's say that it's inches. If we use our abbreviation, we would do the IN with the little 2, and so square inches. Now, if you have a rectangle and the length is 10, and the base is 6, we still do 10 times 6. Length times width is the same in a rectangle as base times height. And in a square, base times height, length times width, or side squared all work the same way. Let's say in the square, the length of the side is 6. We would be doing 6 times 6 because every side's the same length. 6 times 6, which is 36 square inches. Again, if we're doing inches. Don't forget the perimeter is found by adding the lengths of the sides. Sides here being the key word, okay? Meaning on these parallelograms where we don't use the side for area, we would for perimeter. We would add the length of this side and this side, or double it, because those are going to be the same numbers, and then the length of this side and this side. So if we were using this same idea here, that the height is 6, the base is 10, and the side is 7. We already said that the base times the height, 10 times 6, is 60 inches squared, 60 square inches, so that's the area. The perimeter would be 10 plus 10 and 7 plus 7, this side right here. So 14, 24, 34. 34 inches. Not square inches, just inches for perimeter. So the perimeter of this would be in inches. All right, now let's look at a triangle. Any side of a triangle can be the base. Okay, so no matter what kind of triangle you have, where if it's an equilateral, an isosceles, a scalene, doesn't matter, any side can be the base. The height is the perpendicular length from the base to the opposite vertex. So let's just draw a right triangle. Okay, now let's say that we're going to say that this here is your base. Okay, so we're going to say that the base is 4. All right, so let's look at the definition again. The height is the perpendicular length from the base to the opposite vertex. From the base to the opposite vertex. So here's the base, and we want to go to this opposite vertex. Put a blue dot right there. Now remember, again, key word here is perpendicular. So I can't go in the middle of the base and then draw like a slanted line like that. That doesn't work. That doesn't work because then I don't have a perpendicular height. And I do need it to be a perpendicular height. Okay, so what we're going to have to use is right here. On a right triangle, you're actually using two sides of the triangle because you already have that perpendicular 90-degree angle there in the corner. So let's say that this is 3. Now, with a triangle, it's half of a parallelogram. If I go back to our pictures of the parallelogram, if I cut this in half, what do I have here? I have a triangle, right? That's why, let's go back to our other slide. That's why our formula for area of a triangle is half that of a parallelogram. So that's why we want a base, that's why we want a height, and then we take half of it. Or, as you know, dividing by 2 is the same as multiplying by a half. So you can take the base times the height and divide it by 2 if you'd rather. That's perfectly fine. So, once again, this time let's not draw a right triangle. I tried to make that look like a scalene triangle where all three were a little bit different. And let's say that this is our base and it's 10. Our perpendicular height, remember we want the vertex opposite the base, so that's that vertex. So we're going to be drawing, that's our height. Let's say our height is 2. So what we're going to do is half of the base times the height. So we can do half of the height if we want. We can divide that first if we want. 2 divided by 2 is 1. 1 times 10 is 10. I could do 10 times 2, 20, and then divide by 2, just like here. So again, 10. My area of this example triangle would be 10, and once again we would have a label of square units. So if these are feet, then the area would equal 10 square feet. And our little square there. Okay, 10 square feet. Sorry, my FT does not look very much like an FT. And once again, if you're looking about the perimeter, you're talking about adding the 3 sides. So you would need to know the length of this side, you would need to know the length of this side, and you already do know the length of this side, it's 10. So you would have to add all 3 of those numbers together to get the perimeter, and then it would just be feet. All right, we're going to practice some of these in class. Good luck.